Let's see, and I will share my screen. Cool. Room number, let's see, what do we got? Okay, room number, group 4, I guess. Elliot, Hillary, Isabel, and Lowell.
So we're going to drop 5 nested coffee filters, and we're going to drop them 10 times.
And then we'll measure the velocity, mass, and weight. And to do that, we use the vernier analysis and spring scales.
And this will give us the gravitational field strength and whether the velocity is constant. And this information will help us answer if the velocity is constant, then the gravitational field, the gravitational force equals the drag force.
Okay, so that's one group. So 5 coffee filters, 10 times. You're going to measure how fast it's going and its mass weight using vernier and the spring scale. Okay. Ramsey, Marin, Keen.
Okay, so we decided that for our materials, we were going to use 13 coffee filters, and then we'd also need the spring scale and then the vernier analysis. And we wanted to measure the weight and the mass of the filters, the time it takes them to fall, and then the resistance force.
Okay.
And the information that it will give you is telling us how fast, the velocity is telling us how fast it's falling in the drag, and the mass will eventually tell us how fast, how much the filters weigh.
Okay.
So how does that information lead us to our answers? So the relationship between drag and velocity tells us that when velocity is increasing, so is the drag force. And from my understanding of drag, it would also be helpful to know the amount of weight in newtons that's being put on the air to kind of understand more what type of force is opposing it.
Okay, so a pretty different approach, right? The first group measured, right, if I remember correctly, the first group measured mass, weight, and the speed, and made a statement about if the speed is constant, then the drag equals the weight. This group says they're also going to measure the mass and the weight. They're going to measure how long it takes to fall and the displacement. And then they're making a relationship between the drag and the velocity. Okay, so that's a slightly different way of thinking about the problem. This group.
We were going to use 10 coffee filters, and then we were also going to use the spring scale and the vernier analysis.
So the weight of the coffee filters will tell us how much gravitational force is acting on the coffee filters in newtons, and the vernier analysis will tell us if the velocity of the coffee filters falling is constant or not. And so the spring scale will tell us the gravitational force, which will, if the velocity is constant, the gravitational force equals the drag force. So if we know the gravitational force, then we know the drag force.
Okay, so this group, a little bit similar to the first one, but some interesting differences. No mention of mass, which is interesting, right? First group was measuring the mass and the weight. The second group was measuring the mass, if I remember correctly, right? And the weight. This one is just measuring the weight. 10 coffee filters. Okay. Julia, Hayden, Christopher, and Ruby.
We also decided to use 5 coffee filters along with the vernier analysis app and spring scales.
Yes.
Wait, Ruby, are you going for this part?
I thought I was doing the what will the information give you?
Okay, we're gonna use the veneer analysis app to measure if the coffee filters are moving at a constant velocity, and that would mean the drag force is equal to the gravitational force.
Okay, we're going to measure the weight of the coffee filters and the velocity of the coffee filters. And this information will give us, the velocity will tell us how fast the coffee filters are falling and if there are balanced forces or constant velocity.
Cool.
And we also did like a force diagram thing to kind of just like show what we were talking about. Then so if the forces, if there was constant velocity, then there would be balanced forces. So the drag would equal the gravitational force. So we would put like congruency marks.
Cool. Like it. And last but not least, LR, Lucian, and Tate.
Alrighty. Yeah, we are planning to drop also 10 coffee filters at once. And we're planning to measure the velocity and that should be mass of the coffee filters using the Vernier video analysis and our spring scales. That'll give us the velocity and mass of the object, which we can use to calculate the drag. We've also included here like what we can do if the velocity isn't constant. Ella, would you like to explain that?
Yeah, sure. So an object on Earth gains 9.8 millimeters per second of velocity for every second it falls. We can figure out how fast the coffee filter would fall without drag / air friction. So if we can then compare it to the actual velocity of the coffee filter, we can compare to and find the difference in getting the difference in velocity. This difference is how much the filter has been slowed by the air. And all we need to do is multiply by the mass of coffee filters to find the force exerted by drag.
Okay. So you have now heard all the different groups. Now it's time for you to ask questions of each other. And again, like the questions, like if you think about the point of the whiteboard meeting, it's to get clarity, to get consensus, right? Clarity and consensus, and or consensus, right? I'm not sure we're going to get consensus because we all have slightly different experiments. They kind of look all the same, but they're a little bit different each one. But clarity. And when you're asking the question, it could be clarity for yourself, or you asking the question can force the group to actually get clarity for themselves. Like if there's something they did not actually specify in their protocol, like then it's up to, then it's a way for them to say, oh, maybe I didn't think about that. Okay, so go, questions. Is there any, yeah, Ramsey?
So, I was just like fiddling around with the coffee filters, and I tried different amounts of coffee filters, and then I noticed that the more coffee filters, the faster it dropped. So I was wondering why each group chose the amount of coffee filters that they did. Did you guys think it was easier to choose 10? Did you think it was easier to choose 5?
That's a great question. Thank you, Tate. Actually, can we do an experiment? Can you guys just talk? Like, just notice if anybody else wants to speak and just speak up, right? Like so that I don't have to call people. So it's like a little bit more natural. Let's see if that works. Tate, you're up.
Yeah, first, it's a little bit hard to see everyone when you're screen sharing, so I'm not sure if anyone else is going to be talking. But to answer Ramsey's questions, like for example, my group chose 10. It's a little bit arbitrary, but we chose something larger, so it could more easily be measured with the spring scale. So like for example, if we measured one coffee filter, the odds are it would just tell us it weighs 0 kilograms or something.
For us, we kind of just chose a number and just went with it.
I was just wondering how the each object gains 9.8 milliseconds of velocity for every second it falls, or I guess it's
Meters
not,
per
or
second.
meters per second. Yeah, not milliseconds. So is that entirely true, or is there at some point where it reaches a kind of a constant velocity? I don't know, because it seems like things would fall at different rates or whatever.
Oh, oh, okay. It is entirely true. If there's no air friction, and yeah,
Right.
it's kind of weird because like it seems like heavier objects would fall faster, but it's actually that they just fall with more force.
Yeah. Well, objects that have denser mass fall faster because there's less air resistance. Yeah, I was just wondering.
Other questions to other groups? I'm going to go on record that I don't think I understand for group one, for the room one, I don't understand the last sentence. Like all we need to do is multiply that by the mass of coffee filters to find the force exerted by drag. I'm just going to go on record that when you write a sentence with that inside of it, I'm not exactly sure what that refers to. And so I'm not sure what you're multiplying, but that's, you know.
Yeah, I have a question for the groups that's presenting right now. So, your guys' approach is like pretty wildly different than everyone else's, and I don't even think that's a bad thing. I think that's really interesting. But can you like talk to me a bit about how you came up with this idea?
Yeah, yeah, I wrote this down because I kind of wanted a contingency plan in case the velocity wasn't constant.
Mm-hmm.
So yeah, not everything is really explained here, like why newtons per kilogram is like kind of equivalent to meters per second squared. But yeah, we're trying to measure how fast the coffee filter would fall if there was no air, and then compare that to how fast it's falling if there is air resistance, and then find out how much force the air has to exert on the coffee filter to slow it down by that much.
Okay. I don't want to force, like, you know, I ended up on that slide. I didn't mean to end up on that slide. I don't mean for that group to get dinged with all the questions. Are there any other, I guess my question is, how did you guys decide how many tries to make? How are you going to record your data? What kind of data do you think you're going to collect? What kind of data do you think you're going to report? How are you going to report it? Are you going to average stuff? Are you going to, like, what's your, you know?
We decided to do 10 trials because if we all had the same methodology, we could put all ours in one Google Sheets. So then we would have 40 trials. And so I think that's sort of how we came up with 10, because then it'd be 40 with the 4 of us in the group.
So that's interesting. So do you all have the same types of coffee filters?
There was some that came in the pack in the original gun.
Right, I know. I'm the one who packed the bags. I'm here to tell you that they're not all the same coffee filters. So that's one thing. Second, do you think that a coffee filter, right? So example, coffee filter, right? So this coffee filter has lived in that bag for a while. It's getting a little crumbled. Do you think that this coffee filter and that coffee filter, same coffee filter, are they going to fall the same way? Are all your coffee filters equally crumbled? Does that matter?
Well, as long as I feel like they're not crumbled to that extent. If it's like minor differences,
Mhm.
I don't think it will affect
it that much. Obviously, something that has less surface area will have less air drag
Mm-hmm.
on the object. That's why like parachutes and stuff work.
Yeah.
But I think like a minor difference between the four different types or four different like ones we have is not gonna really change that much of the data.
Okay. What if there was a difference between the coffee filters? What would be your solution? I'm just like, what if, right? Like, what if you find that there is a difference between the different people in the group? What's your contingency plan then?
Well, I don't think that there necessarily needs to be a contingency plan. If it's averaged, if it's averaged out between all the different ones, then you'll get an accurate or like semi-accurate uh, reading of different types. Like
Okay.
if it's just averaged.
We could also just collect the data on our own and not share it with each other.
So that could be a contingency plan, right? Like you could, if you share data that kind of looks similar, then you can take averages. If all of your data looks very different, then feel free to take your own data, right? I mean, there's no reason you should average stuff that doesn't look similar. Any other questions from anybody?
I was just wondering,
Yeah,
what would we do with an average if we were to get one?
that is a great question. Thoughts? First of all, average of what?
Well, I mean, I think a lot of groups said that they wanted to drop it like at least 10 times and then they divide the amount of data points that they have. Well, they'd add them up, then they divide it by 10 to get the average, but I just don't know what you do with that average.
I'm also not sure what you're averaging. Like, are you averaging the speeds? Are you averaging the mass? Are you averaging the times it takes for the thing to fall? Are you averaging if you have a constant velocities, are you averaging the constant velocities? Are you averaging the weights? Like, what are you averaging exactly? All of you who want to average things.
I think we're thinking the velocity.
Okay. Okay. Does it matter how high up you drop the coffee filters? Or how long the coffee filters fall for?
I think it matters to some extent. Like if you drop it right above the floor, then it won't be able to reach like its maximum speed. But if you raise it up and it's going at its maximum speed, then I don't think it really matters.
Okay. Does it matter that your coffee filters are nestled really strongly with one another, or can they be a little bit loose?
I think it does matter because like if they're all like spread out or whatever, they're going to generate more drag than if they were all in a pile.
Okay. Again, I'm just generating questions, right? Like I have no idea. Like I don't know the answers to those. I'm going to let you play, but this group, Ramsey, Marin, Kian, you said there's a relationship between drag and velocity. Do you guys have that relationship?
Well, we looked it up, but it was way too confusing. 'Cause there's this like huge like equation that had to do with, like air like liquefying air or something like that. Just because that causes drag. It's very confusing. It's like really advanced.
Cool. So you're going to use that?
We might use what the other groups did, like what Tate's group did with their idea.
Got it. Cool. So let's not So let's stop here. Are there any other questions that you guys have for each other? Once, twice.